Okay, so hi everyone. Hope you're having a good day so far. I have the dubious honor of having the last session of the day, which is basically I'm everything that stands between you going home. So I'm going to be talking about actor-based development with project or lanes is the plan for the last talk of the day. So hopefully that will go well. I'm a bit surprised about the amount of people in the room, which is always nice. So hopefully we can teach you guys some stuff. My name is Klug. I work at a company called Active Solution in Sweden, where we do custom software development on the Microsoft platform. And I've been doing that for the last 25-ish years. And I've had the honor of being Microsoft MVP for the last 15 of those years. So I get to see stuff, used to get to see stuff internally from Microsoft, and now everything is out in the public, so we don't actually get that much more than you guys do. And Orleans kind of caught my attention a while back because it fit into a scenario that I wanted to look at. But let's sort of go back and go, so what is Orleans? So Project Orleans is a cross-platform framework for building robust, scalable, distributed applications, apps that span more than a single process, often beyond hardware boundaries, using peer-to-peer communication. That tells you exactly everything, right? You know precisely what Orleans is now? No. It's a bunch of marketing stuff. They might have updated this. This is an old intro to it. But we'll go in and make it more tangible. But it's kind of funny because I wrote this talk. This is the old talk. This talk I've been giving this for the last 3 years, I think. And when I wrote the talk 3 years ago, people looked at me and went, wait, is Orleans still a thing? That was 3 years ago. I got the same reaction today. Speaker out there told me, wait, does people still care about Orleans 15 years later? And I'm like, yeah, well, yeah. In some scenarios, it is brilliant. And that's probably why it's not really a mainstream kind of thing to work with, because it fits in a very specific area. And yes, when he said 15 years, it's actually almost that. Because it was actually something that came out in 2011. So it's been around forever. And it was because Microsoft decided that their game studio needed to build a little program or a little game called Halo. And when they wanted to do online multiplayer games with stuff like Halo, they needed a way to basically support that in the back end inside of Azure. And they didn't have a way to do that, so they went to Microsoft Research and said, hey, can you guys help us build something that we can use to support Halo? And they came up with Project Orleans. And the idea is that each player in the game gets an actor that represents that individual, and then there's an actor for each game and stuff like that. And they used it like a proprietary thing internally for Microsoft for a few years. And then in 2015, it went open source and it went out to the public, and nobody cared. Nobody kind of cared because A, it's a niche thing that works really well in one area, but also because the previous version was really hard to get started with. There was very little documentation on this is how you get started. Here is some samples. It was all about here are white papers on how the algorithms internally work and a bunch of stuff like that. But with the new .NET, I don't know what to call it anymore. It's not .NET Core, but it feels wrong to say .NET because, well, the not framework version of .NET, they rewrote all of Orleans and focused on making it user-friendly. And it is now ridiculously user-friendly. It's easy to get started with, and everybody can work with it because it's just simple C#. But it is literally just an implementation of something called an actor model. So actor models is based on this idea where you have actors, which are small pieces of code that runs somewhere and represents a thing. I thought it was a marketing slide in the beginning. I just turned it into, it's a thing that runs stuff somewhere. Not very helpful. But you can think of it as a way of basically being able to represent anything you want as a little unit of code that can run somewhere in a cluster. So for Halo, for example, every player's position, score, and all of that stuff can be a little actor. In an online auctioning system, every auction could be an actor. In a fleet tracking thing for vehicles, every vehicle could be an actor, for example. Or in IoT devices, every device gets its own little actor that represents it in the cloud. Now, it's not a strict actor model implementation because Microsoft Research invented the virtual actor model, which basically just means that when you ask for an actor, one of those little services that's running somewhere, you don't have to care about whether or not it exists. You don't have to care about where it's running. You don't have to care about any of that. You just go and say, can you give me an actor with this ID? And then Orleans goes and says, oh, yeah, I can get you one of those. And then Orleans says, looks at it and goes, no, there's no actor like that. I'll spin one up for you and put it somewhere in the cluster. Or it goes, oh, I've seen that actor before. I'm going to give you a reference to that actor. Or, oh, it's not in memory right now, but it used to be in memory. So I'm going to restore it and rehydrate it with the old state and then give you a reference to it. So you don't have to go through the whole, oh, does the actor exist? Yes, no. If the actor is, and so on, it just works. And if you go online and you look at it, there's a good definition of actors. I think this is from Wikipedia. It says an actor is an address, some behavior, and potentially some state. And that kind of makes sense. You can see it. So if you're really old like me and you've worked with .NET technology or .NET stuff for a long time, you remember WCF, right? Services. Yeah, people are, that's old stuff. Yes, it's very old stuff. But imagine it being a WCF service with state that can just pop up at some address somewhere. But in the old version, you would go like this. Orleans is making it a little bit different because you don't need a full address. You just need the ID. But we'll come to that. I have another way of defining this, and that's think of it as an addressable stateful service that can just be easily created and called. So it's like, oh, I need another service, give it to me and I will call it. That's all you need. Or an even better way of looking at it from my point of view is like a distributed IOC container with named singleton instances only. Now, I love being able to say this because, as I said, I've been around for 25 years doing this. It's not until I think .NET Core became popular that people, like the general public, got used to using IOC containers and got to know all of that stuff. But this is what it is. You're basically getting a distributed IOC container that can hold services, but every service is a singleton and every service is named or keyed. So it's basically, it creates keyed versions for you. So if you look at the way that IOC containers work today, if you spin up a new ASP.NET Core application or any .NET Core application more or less, you have a web app in this case. The web app has a host. Inside the host, you have your application, and the application can go and pull services out of your IOC container, right? We've all done that. It's part of building ASP.NET Core applications. The problem with this model is that once you start load balancing it and scaling out, which we all do nowadays more or less, you have this problem that IOC containers, there's one per instance, which causes a lot of problem, which is why most people say, oh, your services in the IOC container should be stateless. Because once you add state to them, you're kind of screwed, right? Because all of a sudden state changes over here, then you have to figure out a way to tell all the other ones that, hey, this state changed over here, so the state has to change there, otherwise you get inconsistent behavior from your application, which is a bit of a pain. Orleans does this. So it basically goes and says, hey, I'm going to give you one IOC container. It's going to run in all of your instances. I will take care of all of the network communication and everything between the different hosts. And you just go and say you want a service and you call functions on it and it will do stuff for you, whether or not it's local or if it's on a different machine. Which kind of sounds too good to be true, but it's actually true. It's ridiculously simple. Oh, and yeah, on top of that, it's single-threaded. So, and no, okay, let's back up. Orleans is not single-threaded. That would be stupid. Orleans is made for massive scale. Making that single-threaded would be stupid. It's like, yeah, we run Halo on it on one thread. It's not the way it works. But every grain is single-threaded by default. So there's no way of two calls coming into the same grain at the same time. So you don't have to lock and keep multi-threading in mind. You just go and say, I'm going to use this thing, but it's only going to be single-threaded, which makes development in a big environment a lot easier. And then if you feel brave and you think you can do like multi-threaded development, you can go in and say, I am much better than you are. I'm going to make it multi-threaded and handle all of my locks yourself. And then you're likely going to shoot yourself in the foot. But you can, if you feel like that's the way to go. But, and I'm sorry about this, Microsoft, but I'm going to say this. Because it's Microsoft, they couldn't reuse the naming standard that they'd all come up with, because it's the actor model, and the actor model has nodes, and inside the nodes there are grains. Or sorry, there are actors. In Orleans, a node is called a silo. And inside your silo, you have grains, not actors, and you run your silos in a web farm. Yep, dad joke on technical level. It's ridiculous, but you get used to it. You just need to remember it's grains and silos. And instead of using an address, like I showed you that an actor is basically an address, functionality, and potential state, the address becomes only grain identity. You just need to tell it the ID of the grain. You don't need to know what server it's on, what IP address it responds to, and things like that. So instead, a grain becomes an identity, which is a combination of the type of grain, in this case a user, the ID of the grain, in this case zero-col, which is just a string. Your IDs can be grids, ints, strings, and a combination of those two, or three. You get some behavior, and in Orleans, behavior is literally just a C# class that inherits from grain and implements an interface, in this case, iUser. And state, well, as long as your instance is in memory, it's just variables inside of your class. You don't have to care. It's just, as long as it's there, you have variables, and that is your state. So you can look at your variables, and you can read them, you can write them, and all of that. But because it's running in .NET, and .NET is a garbage collected environment, it means that any grain that has been around for a long time will be garbage collected if you're getting memory constraints on your machine. So your grain might die and get garbage collected and disappear. Now, to solve that, there is built-in persistent storage in Orleans as well, so you can go and actually, whenever you want to, from your grain, say, hey, can you just update my state, because I just updated my state locally, go and put that in the database, so if I get garbage collected, I can rehydrate that state and use it again. And then we have the get versus create. This is where the virtual stuff comes in. So you use a grain factory to get hold of grains. So in this case, I'm asking the grain factory for a grain of type iUser called zero-col. And for the record, this is not exactly how it works under the hood, but this is a good way of thinking of how it works under the hood, just so you're okay with that. I ask for that grain. I ask one of the silos in my cluster. The silo 1 doesn't have that grain in memory, so it goes, hey, silo 3, do you have that grain? No, I don't have that grain. Hey, silo 2, do you have that grain? No, I don't have that grain. Hey, well, silo 3, can you create one of these grains for me? Can you create a user? It creates a user. It returns a reference or a proxy or an address to that grain. And then that returns as a proxy. I get a proxy out from my grain factory. I can start calling the code on my instance. Now, the reason that I'm saying it's not working like this is because it doesn't actually go to each one of the silos asking, do you have this, do you have this? It's not like a big game of, do you have a grain? It actually has a way of organizing what grains goes onto what silos that is smarter than that. But let's just imagine this is how it works. But now it's in memory, so next question that comes in basically goes, hey, can I get that grain? Oh yeah, it's silo 3, do you have that grain? Yeah, I have the grain. I get the grain back, I get a reference, and I can start calling methods on it. Very simple. But the cool thing with this auto-creating of grains is that A, I don't have to know whether or not it exists. I can just say get grain. But if a node falls offline or a silo falls offline, we're doing a rolling update or somebody pulled the plug, something happened to that machine, there's no extra code needing to go into that. We don't need to handle that. Because what happens when the next request comes in, silo 1 goes, I don't have it. Silo 2, I don't have it. Silo 2, can you add one? Yeah, I'm going to add one. And then I get a reference back. So it just simplifies things. We just ask for it, and we shall have it, and then it works. Let's have a quick look at how to create a grain. So I have a little piece of code here that I've written. And you can see here, we're going to focus on these 3 repos here, or projects here. There's a small one called Tracking Simulator. We don't need to go into that, but it's basically a thing that emulates 10 things sending out position updates every second. It's just a simple way of showing a thing. Then we have a silo, which is where, well, we're going to host our silo. That's a console application. That's where we're going to focus. And a console application like this is kind of cool because Orleans uses the iHost interface, which is in every single .NET application today, which means that as long as you have an iHost, you can use Orleans. So you can put an Orleans silo inside of your ASP.NET Core application, or inside your console application, or in theory, inside of your WPF application. Please don't, but you can. It's just stupid to put it in a WPF application. But it's kind of nice. So that's all I've got in this project. And then inside here in my grains project, I have nothing. But the idea here is that we put our grains, or rather we put our interfaces for our grains in a class library that both the client and the server can access so that it can share the same interface. The client needs the interface, the server needs the actual implementation. We can also have a quick look here. Actually, let's do it like this because it's faster. We can see here that in my grains, the common project, I have a reference to the Orleans SDK. That's all you need. There's one NuGet package. That thing we can kind of ignore for now. I only need that because I'm going to have a demo on doing custom persistence. But other than that, one reference to Orleans SDK to be able to create grains. In the silo, because it's a server-side part, you have a reference to Orleans server. So only thing you need. Ignore that and ignore that. Those are optional extras because of my demo. You need one reference to that thing. And in the client part, my simulator, it needs Orleans client. That's all you need. 3 NuGet packages in 3 different projects. That's all you need. So the first thing we need to do is define our grain. And because I'm going to do location tracking of something moving around, I'm going to need a location tracking grain. So I'm going to go ahead and I'm going to write that. There's going to be a lot of snippets. I'm trying to keep them small, but you really, really, really don't want to see me type this much for any extended period of time. So we have the interface here, iLocation tracking grain. It inherits from or implements iGrain with string key. Now the cool thing is if you go into this and you expect to find a bunch of cool stuff, iGrain with string key doesn't actually have anything on it, and it implements iGrain. And if we go into iGrain, iGrain doesn't actually have anything on it because it implements iAddressable. And if we go into iAddressable, it doesn't actually have anything on it. That's a useful implementation. No. There is a source code generator that because you inherit from or implement iGrain with string key, it generates stuff for you. So that's why we need to implement that. Other than that, it's just a C# interface with every method that you want to call has to be async because we don't know if it's going to go over the network or not. So it has to be asynchronous. But other than that, C# interface. Nothing complicated. Also, I'm taking a location here. Anything that goes over the wire needs to be serializable to be able to go over the wire. To make it serializable, you do not use iSerializable or a serializable attribute like everyone else would use. You use generate serializer instead. And you need to put one of these ID attributes on every property that needs to be serialized. Reason for this is that it serializes down to protobuf instead of JSON, which means that you have to put these attributes on it. It makes it more efficient, but it's kind of cool. And also, if you just put this on there and then go control dot, it will actually say add ID attributes for me, and it will do it automatically. So it's fairly easy to do. Now that I have my interface, I can go and create my actual implementation. Once again, simple C# class, inherits from grain that gives you a bunch of base functionality. I don't know if they have implemented it yet, but they are going to implement a way where you don't need to inherit from grain, but instead you need to get 65 things injected into your constructor. I don't know if that makes it better, but if you don't like inheritance. And it implements iLocation tracking grain. And I have a constructor. All it really does, it prints out creating location tracking grain with the key of the grain. And then every time you do a location update, it basically does a console write line. Now remember, all grains are running in the console. It's just a thing that runs in the console. So console write line works fine. It's just a thing. It's just C# code running in your process. So that's the whole implementation of my grain for now. So I'm going to save that. Inside of my silo, I need to add Orleans. And I said this focused a lot on making Orleans easy. So you just do use Orleans. It takes 2 parameters. It takes a context and a silo. And to set it up, I need to give it some form of clustering information. So I'm going to run it locally. So I'm going to go use localhost clustering, because I'm only going to run one silo on my local host. So that's a predefined setup. And I'm also going to go and add a dashboard. So I'm going to go silo.use dashboard, like that. That's the entire configuration for my silo. Nothing else needed. It just works. And for the client in this case, which is my little simulator down here, I need to add a client part to it. So I'm going to go use Orleans client. Orleans client takes two parameters, CTX, the context, and a client. And the configuration of the client looks like this, which is very similar to what I wrote in the server side of it. That's it, I'm done. My client will now automatically start working together with my silo. That's just how it works. Now, inside my simulator, I need to get a cluster client. So the way you get a cluster client is we have our host, which has services, which is actually, that looks pretty okay. So we do get required service iCluster client. That gives me a client that can communicate with the silo. Inside this little loop here, you don't need to know, but basically it runs 10 things that every second, as I said, sends a location update. That's not the important part. The important part is the Orleans stuff. So in here, I'm going to go and say var grain equals, that's why I shouldn't be typing, cluster client dot get grain. It's going to be an I location tracking grain, and I'm going to call it name. So name is basically simulator's dash or space ID or number of simulator. And then once I have my grain in here, whenever it needs to do an update, all I have to do is say await grain dot update location. So it's just like using a C# interface. And then it needs location, so I'm going to take my point and I'm going to go to location because it happens to be the wrong format. That's it. That's all we need to do. So if I start this now, I fire up my silo, debug, start new instance. This is probably the least impressive demo you're going to see throughout the entire conference, because this is what you get. A terminal. It's not exciting at all. But the kind of cool thing is if I pull up my simulator and we do debug and we start instance, you will, oops, wrong keyboard combination. You will see that my silo is now getting all of these updates. So if we scroll up, you can see here where it says, well, I can't because it keeps scrolling down, but somewhere up there it says creating grain with ID and everything, and you see every position update coming in. Not impressive because it's running two processes on my local machine, I know, but it could just as well have been a cluster with 500,000 silos and it would work the same way. It would be even less impressive because it would be 10 silos with a thing going up every second, 490 silos doing nothing. But I also used that thing that said use, so in the silo I said use dashboard. That means that it actually adds a cool little dashboard for me automatically, because all I have to go is go to localhost 8080, which is the default port for the dashboard. I get this little dashboard here that actually tells me everything that's going on in the cluster. How long does each one of the requests take? Are there any failed requests? How many grains are running in my silo right now? So there are 10 activated grains in here at the moment. I can see that there is one silo in place, and this is the address for it and all of that. All I need to do is use dashboard, and we get this dashboard. Hey. Kind of what we expected. So that's how easy it is to get. I need to learn the right keyboard shortcuts. We're going to cancel that. We're going to cancel this. And yes, I canceled it in the wrong order. There you go. And then I'm going to go here, and we're going to do that. Okay, so we have seen that it's actually quite easy to start grains. And if we want to start silos, and we need to basically cluster them, we need to make them sure that they can communicate. The cool thing is that silos need 2 ports, that's it. As long as you can put a silo inside of an I host and you can give it 2 ports, you have a working system. By default, you get port 30,000 and 11,111. Port 30,000 are for clients communicating with the silo. 11,111 is for silos communicating between the silos. Only 2 ports you need, and you can move them around if you want to. So they don't need to be those ports. I showed you localhost clustering that sets up one silo on your local host, port 30,000 and 11,111, you're good to go. Looks like this, you saw it, use localhost clustering, and the client side is the same thing, but client instead of silo. If you want to run more than one instance on your development machine, you can, or during development, you can use development clustering. When you do development clustering, you basically tell your silo that, hey, I want to do this, and you give it a primary silo. So one silo becomes the main one. It's the thing that keeps track of everything. If that silo goes down, your cluster goes down. So it's called development cluster for a reason. You don't want to use it in production because you have one silo that will kill your entire cluster. But you basically point it at the IP address of a specific node in your cluster, and it starts working. And then for the client, you use what's called static clustering, and you can give it one or more IP addresses, and it will basically load balance between the different silos in your system. And you can have more than one silo, either on your own local machine, which is what I'm going to show you, or you might at your office have a couple of extra machines to actually try the network communication and all of that stuff. But the coolest thing is clustering with a clustering provider. So clustering is complicated and has a bunch of setup. But with Orleans, you have something called a provider. So in this case, it uses an Azure storage clustering provider. So you just say, hey, I want to use Azure storage clustering, and you give it the connection string to an Azure storage account. That's all you do. And for the client, you do the same thing. Use Azure storage clustering. That's all you need to do. Whenever a silo comes up, it registers itself in Azure Table Storage and says, hey, I'm available. This is my IP address. This is my port. And then every silo knows to look in that table to find all the other silos. And whenever the client needs to talk to a silo, it looks at that table and it figures out where it can go to talk to the silos. So you don't have to configure a bunch of things, which is kind of nice. You also have ADO.NET clustering. So if you don't want to use Azure, you can put it into any ADO.NET supported backend stores like Microsoft SQL Server, for example. That's the server side. That's the client side. You kind of get the point. Server side and client side is identical. But that makes it very easy for you to play around with. So let's see if we can do some clustering in here. So I'm going to jump over here again. And we're going to go to my silo, which is over here. First thing I'm going to do is I'm going to remove those. Because I can't have the dashboard running at the same time because the dashboard defaults to port 8080, which then would collide if I start more than one. So we have to do some stuff. Then we say silo.use development clustering like that. I need to give it a new IP endpoint. I need to give it, so I'm going to give it IP address.loopback. You don't necessarily need to give it IP address, but because of Docker and networking is complicated, I have to do it on my machine. So I'm just going to tell it that this is the address that the main silo is going to be on. And I want you to use port 11,111 when you communicate with the main silo. The next thing is to tell this silo what endpoints or what ports it's going to use. So I'm going to go configure endpoints. And then I can tell it where do I want this specific silo to be. So I'm going to go new IP address dot loopback. Nope. New IP, no, sorry, it's not new, it's me. IP address dot loopback like that. It's going to be on port 11,111 and port 30,000 like that. Now, the problem with this is that if I spin up more than one silo on my machine, I start this process more than one time, what's going to happen? They're going to use the same port. It's actually, silo 1 is going to come up and go, I'm on live, and then silo 2 is going to come up and say, I'm stealing your ports, and it's going to break down. So to fix that, to be able to run it on my local machine with multiple instances, I'm going to do this ugly stuff. Basically going to go and look at my processes on my local machine, find all processes called location tracking silo. If there is one, I'm going to set port spread to 0. Otherwise, I'm going to make a random number between 0 and 1,000. And then I'm going to go down here and basically say plus port spread and plus port spread like that. Basically giving each silo a unique endpoint. Then in the client side, I need to make a change as well. So I'm going to go in here. We're going to change the use localhost clustering into, that was not what I wanted to press. That was not what I wanted to press. That's what I wanted. We're going to say client.use static clustering like that. I need to tell it where do I find the silos. So we're going to go and say IP, IP address dot loop back, and then, hey, it's going to be available on port 30,000 like that. Why is this complaining? Because I am an idiot. IP address, no, sorry, IP endpoint. There we go. Why is that complaining now? Because it's capital P. Code is so annoying. Okay, so that's kind of it. If I now go and start, let's start 3 of these silos. So we're going to go add new, start new instance, start new instance, start new instance, and then we go and say simulator, start new instance, and then we look at this. Why did I not? Oh, there they are. So we will now hopefully see that there is a somewhat even distribution of. Why did I not only get? I only got 2 for some reason, but you can see that it basically distributes my calls between the 2 different silos in here, which is kind of what we expect. And if I go ahead and I kill that silo over here, it's going to complain a little bit. And it, okay. So I killed the main silo. So now you see the problem of having development clustering. If you kill the wrong silo, and this is fun. I've done this talk many, many times, and I've always managed to kill the one that I'm not allowed to kill. Kind of annoying. But it kind of works. It's kind of sweet like that. Azure storage clustering is even easier because all you need to do is you go in here and we say, comment that out. And we add this. So I'm using use Azure storage clustering. I give it, so this is obsolete. There's a different way of doing it now, but this still works. It's basically giving it a table service client with a connection string to Azure and the same configure endpoints with the port spread. And if I go over to my client and we comment this out, getting used to a Mac, and then we do 05. We kind of call the same thing. Use Azure storage clustering. We give it the table storage client. Then we pull up a silo or a couple. That's 1. That's 2. That's 3. And a simulator. That's 4, like that. We go here and we'll see here that it has a bunch of output because it finds old dead silos in that type of table storage, but it kind of figures that out and marks them as dead, and then it basically spreads the load across the 3. If I kill that silo, I can now kill whatever silo I want. It doesn't matter because they all use table storage. It just keeps on going. Now, the little secret trick here is that if I pull up a new silo, there is no automatic load balancing, so it won't actually go and put anything on this node whatsoever. Everything will keep running in the 2 old silos until one of the old silos is killed off. So if we pull up this and we kill that one, you will see that a part of the load from this gets redistributed to the new silo. So if you pull up a new silo, nothing gets rebalanced. You have to basically pull down stuff to get, or anything new will pop up on the new silo. But local or table storage clustering is a very cool option of not having to do a lot of stuff on your own. So I'm just going to kill these. Die. There we go. So clustering is fairly easy to set up. But there's also a cool feature that I'm going to show, which is maybe not hyper useful, but it's kind of cool from a technical point of view, because you're going to look at it and go, yeah, that doesn't look very hard. And then you're going to go home, and if you spend more than 5 minutes at home thinking about what I just showed you, you're going to go, wait, how did that actually work? Because there's a bunch of network magic going on that Orleans just sorts out for us with observing grains. So observing grains is a way for grains to expose functionality. So basically say, I want to tell people that something has happened, and then you can create a client that can listen to changes. And we do that using something called an iGrain observer. So you implement an iGrain observer, and then that starts listening to, or you create an interface with iGrain observer, and then it magically starts getting information from your grains to whoever is listening over the network, which is just, I don't know. I keep saying this is magic, but it is really magic when you start thinking about it. I still don't know how they build it, but it works. So let's have a look at how we can do grain observation. So before I do that, I'm just going to go and say, I'm going to use localhost clustering because I don't want a bunch of nodes here anyway. So we'll just go back to localhost clustering, like that. Here we go. Okay, so the problem with grain observability is that you can only observe one grain at a time. So say that we had a marathon, so the movement of the dots, the positions is actually me out running at home. So imagine that this was covering like a marathon with 1,000 people. Having a 1,000 observer things being sent in is kind of wasteful. So what we're going to do is we're going to have all the grains with location tracking report to a common grain that has like the last update only, and then we can observe that one grain to get information about all the grains, which is just way more efficient. So I'm going to go ahead and in my grains here, I'm going to start a new class or create a new class. So new item, I'm going to create a class and I'm going to call it dashboard. Actually, it was supposed that. Getting too old to see this screen, dashboard grain like that. And then I'm going to replace all of the content in here with this. So you see it's an iDashboard grain, iGrain with GUID key. In this case, I'm using a GUID. The thing is I'm going to fake this because I'm going to use the same GUID in every place. I'm going to go GUID.empty. By using GUID.empty in every situation, you get a singleton grain because there's only going to be one instance of that, which means that everybody talks to the same grain, which is kind of simple. So I have a dashboard grain that's going to have an add position updated, which is going to be called by the location tracking grains. We have a subscribe and unsubscribe that takes an iDashboard observer, which is basically I want to subscribe to changes. And then the iDashboard observer is an interface that implements iGrain observer. And it exposes a method called onPositionUpdated that takes the client ID and or a list of client IDs and locations of their last updates. And it returns void because this doesn't actually have any guarantees on delivery whatsoever. So it's a best sort of, I'm going to try my best, but if it doesn't arrive, it's not a big deal. You can back this and use something called streams, which is actually backed by messaging and things like that. But for this, I just wanted a cool, simple demo. Now, after that, I need an implementation of the dashboard grain. So let's go ahead and implement that. So I'm calling it a location dashboard grain that implements iDashboard grain. It cannot be called dashboard grain because if you use the dashboard, the Orleans dashboard, it already has a grain called dashboard grain. And by default, it only uses the class name, not the namespace for the naming. So they collide and the thing blows up in your face. That only took about half an hour to figure out when I failed that for it. But yeah, that's why it's called a little bit different. Other than that, it's a C# class. It has a dictionary of current positions. It has a list or a hash set of observers, and it has a disposable timer. In the constructor, I register a grain timer. So the way that you register a timer here is done in this way because it goes into the single-threaded nature. So even your timer callbacks will be on that single thread instead of being a multi-threaded thing. So you use this method to create a timer. And then basically once every second, it's going to send off the updates. So we need to implement that. But first of all, when a client calls and says, I have another position, all we need to do is look into the current positions dictionary and basically add the new update for the new position for the client. That's it. For subscribe, well, just add the observer to my list of observers and we're good to go. Unsubscribe, other way around, remove the observer and we're good to go. That's all we need. Send updates, not very complicated to implement. It basically takes all of the current positions, turns them into an array of client ID and locations, calls the onPosition update on every one of the observers, and returns completed task. That's it. It's all very basic C# stuff. Now, to get that to work, we're going to have to get our location tracking grain to send updates as well. So the way that we get the location tracking grain to send updates is that we add a constructor. Actually, we do it here. We're going to do iLookGrain factory. Grain factory. Can I get some help? iGrain factory. There it is. Grain factory, like that. We're going to persist that as a variable. There we go. So I'm going to save my grain factory, and then every time I get an updated location, I'm going to go ahead and make a little change to this. I'm going to make it async, and then that didn't come out spelt very well. Thank you for the help for the people who are watching me code. It's not very nice of you. Here we go. So in the update location, it basically writes out the thing like it did before, but then it asks the grain factory, can I get the dashboard grain based on GUID empty? And then call update, add position updated to it. That's all we need to do. Now, to view this, please don't judge me, but I have built a WPF application. There's a reason that I'm running on a Mac and using Parallels on Windows, because I couldn't kind of use that in Mac land. So let's just ignore it's a WPF application. That's fine for now. So in my main window.xaml, there is stuff. Now there's less stuff. But what's interesting is, the only interesting part is that on initialize, it actually creates a host internally. So it creates an iHost instance inside of WPF. It calls use Orleans client. And then after the start async, it basically goes and calls on host started. And then when it's closing down, it does a bunch of really cool on stopping, continue with, dispatcher mumbo jumbo. But in the end, it kind of calls stop async here, which is, or sorry, it should call on host stopping is called there. Sorry, there it is. So what we want to basically look at is what do we do in on host started and host stopping. So the first thing I need to do is I need to create an observer, and I have some code for that. I never code on a project without snippets already built. So I build a dashboard observer that implements iDashboard observer. And it's a very simple one. It takes a callback in the constructor, and then whenever you get an on-position update, it calls the callback. It's just a little wrapper for my callback method. And then in on-host started, we go and create a cluster client. Then we go and create get the dashboard grain. Then we create a dashboard observer, and I did not put var here because I explicitly need to create a field with that. Then once I have my dashboard observer, I go and create what's called an object reference using Orleans. Once again, I need to store a field. I'll explain why. And then I call dashboard grain.subscribe and then pass in my observer ref. The reason for the variables being stored up there is that I'm going to use the observer ref to unhook my observer when I'm done with it. We also need to keep a handle to the observer. The reason for that, I learned after, once again, a couple of hours of debugging. This is actually under control of the garbage collector as well. And internally, the object ref thingy only keeps a what's it called, weak reference. So whenever the garbage collector runs, it actually garbage collects my observer. So my app will run perfectly fine for about 22 seconds, and then all updates stop working. It doesn't say anything, it just stops getting updates. Yeah, that was 2 hours of my life I'm never getting back. Now you know that you keep a reference, and that's the way you make it work. And finally, in stopping it, all I need to do is get hold of my cluster client, my dashboard grain, unsubscribe, and I'm good to go. Now, let's see if we can get this to work. I am going to start a silo. We have a silo. There it is. I'm going to start a simulator that simulates me running around in Stockholm in 10 instances. So Chris, why did you choose yourself running around Stockholm? Because I didn't have any other great way of doing anything that was interesting, and getting your GPS positions from your watch is really, really simple. That's why. And then I'm going to start my dashboard, and this is where it gets cool. Invalid credentials, by the way, if Microsoft is looking, is bullshit. I have registered my credentials. It does not handle them, but I also think that the Bing Maps control for WPF might be out of support for the last 15 years, so it might be that. But you can see things are moving. I'm running at a ridiculous speed if you know the size of this map, because I've sped it up like 1,000 times. But it's kind of cool, and if you start thinking about this, I created an instance of iDashboard_server, which is a class with a callback. I gave that to Orleans and said, I want to start listening to things, and magically, stuff inside of a silo over here started calling a callback in my WPF application over here. You might not be impressed, but I am very impressed. Not by my code, but by the guy who wrote Orleans. So that's kind of cool. It's a great way to do like an overview of what's going on in your cluster. And you can obviously use it for more than visualization. You can basically get any updates out of the system that you want. Now, persistence is also a big thing, because so far my grains would have disappeared. If anything happened, they would be garbage collected and all updates would be gone, which would be fine in my demo, but not in the real world. So you can do persistence using persistence providers like ADO.NET or Azure Storage or Memory or DynamoDB or Redis or a bunch of different things. And it allows, if you use these, it allows Orleans to basically store your state in a JSON serialized form in a storage container. That's it. Now, that is not really useful in all the cases, because often our grains will actually be a representation of something in our domain, right? So when we want to update the state of something in our domain, we want it to go to our database. That's kind of cool, because you implement something called an iGrain storage that has a read state async, clear state async, and write state async, and you're good to go. Then you are responsible for persisting the state in whatever way you want. So you can have your grains go and say, I need to persist my state, and it can go off and write to your SQL database into your tables in your format. You can even get it to pull state from a bunch of different storages. So you can go and say, I want to get some of the state from table storage, some of it from my database, some of it from this thing over here, and it basically gets joined into your grain. And the way that state works, question? Best practice on write state. In what way? Yeah.
If I have, for example, some pattern connector, and I just keep it in, I should write it immediately, or I can do that on the activation.
So first of all, so the question is, how do we do write state during activation? Is that your question? Or should you do it later on? Deactivation, sorry. No. So for the recording, how do we handle write state? Do we do it on deactivation, or do we do it continuously? I would recommend continuously, because deactivation only happens if you have a graceful shutdown with garbage collection, or through garbage collection, or a graceful shutdown of the silo. If somebody pulls the plug, so whenever your state changes in a way that makes sense for you to have it persistent, then call write state async and be good with it. And it runs as part of the actual call. So if your persistent fails, the whole call fails, and then you have to roll back and things like that. So use it during whenever your state changes continuously. And the way that you handle state is you get injected an iPersistent state of T, where T is the state type that you have, which is basically what you want to save between activations. And then you mark your iPersistent state variable or parameter with persistent state attributes, and telling it, hey, I want to get this state, and I want to get it from this specific state provider over here. And then in your constructor, it basically, like this, it injects an iPersistent state of, in this case, my state. And then on iPersistent state, you can go and say, basically say update state or refresh state or whatever you want, and that under the hood then calls your provider, and the provider, the persistence provider, and that sorts everything out. So let's figure that out. We should be good to build that. I've got all of 10 minutes to build a state provider. What can possibly go wrong? Let's see if I can, I need to go over to Windows. Here we have it. So we're going to start out with changing our dashboard grain a little bit. So what I want to do is I want to make sure that the dashboard grain always keeps track of the latest position updates, so that if anything happens when it comes back online again, the last update is always available for some reason. So I'm going to go into my dashboard grain, and I'm going to create a class in here. So I'm going to go to, actually, let's do down here, location grain. There, we'll do POI16. So I'm creating a class here called dashboard state. And all I need to know is basically a dictionary of last known states. And then I'm going to go ahead and create a dashboard storage, state storage. So I'm going to go and create add new item. I'm going to call it dashboard state storage. Can't trust you for spelling, so I'm going to check it. Then I'm going to replace that with this. So there's a bit of code here, but it's a stupid state store that basically stores a JSON file. Not very brilliant. So it starts up with a storage path. It looks if that path exists on my machine. If not, it creates that directory. And then in clear state async, I throw not implemented exception because I don't support clearing my state for this storage provider. So we take that away. Read state async. So what I get in is I get a state name, which is a string that you can configure to basically tell your state something, or storage mechanism something if you want to. You get a grain ID and you get the state that you want to persist. Then I look at, hey, the states that you passed in, the T in this case, is that location dashboard grain dot dashboard state. If that is the case, I'm going to go ahead and basically create a JSON file and store that to disk. And, oh, sorry, that was for reading. It will find that and read it when you want to read it. And for writing it, I will go and write the JSON to disk like that. Very stupid state storage, but it kind of fills the purpose for a demo, right? You could do whatever you want in here. Now, once I have my state storage in place, we can go ahead to the silo. We can go into somewhere around here, and we can say, hey, oops. Why did that not come? Add keyed singleton. Ah, come on. Add. Sorry, it was, am I, add keyed singleton doesn't work, but add keyed singleton works. Okay. So I'm just going to tell it that, hey, there's a dashboard state thingy that I want to use, and I'm going to call it dashboard state storage, and then I'm going to give it an instance of my dashboard state storage. So that should be good. Now, inside of my dashboard grain, I'm going to have to make a little change to my constructor. So in my constructor now, I'm going to add that. It now takes, let's put this on 2 lines so you can see it. It now takes an iPersistent state of dashboard state, called state, and I've marked it up with persistent state, saying that I want to use this implementation for state storage, and then I pass in dashboard state, which isn't actually used, so you could pass in Donald Duck here, it would work fine, because I'm not using that string. And then I need to update my current positions, because current positions here is actually going to be state.last known positions, like that. And then we need to make a little change to send updates. I'm going to make it async. And then at the end here, nope, at the end here, we're going to do await state dot write state async, like that, to persist my state. So every time I send up now update, it will persist the state. Now this is going to take 2 seconds for me to demo, because I need to start a silo. This is kind of an annoying way to do it, but it's the only way to do it. We start a silo. We start a simulator. We should see this thing doing things. It says sending updates, so it's obviously persisting it as well. So we kill the simulator again, and we kill the grain. Then we start the silo again, or sorry, I killed the silo, and then we start the silo again. And it hasn't gotten any updates, so if I get positions now, it will be my persisted version. So if I go and pull my dashboard, and I go debug, and start new debugging session, it shows the last known positions that was used. So it's kind of easy to integrate the persistence of your grains into whatever storage mechanism you have as well. So I've done we built a proof of concept for doing online auctions where Orleans fits really, really well because of anti-sniping rules and timers and stuff like that. And also the single-threaded nature makes it really simple. And it was kind of nice because we could then do a state storage that basically persisted into the existing thing, and we could just keep working with everything as it was, but have this thing built on the side to see if it works. So grain persistence is nice when you do it custom. A few comments. Threading, as I said, it's all single-threaded, making your life loads easier. But if you are brave enough, you can actually go and control it a bit with saying re-entrant, which basically means that if your grain calls a grain that calls back into your grain, that's okay, you're allowed to do that. You can also do always interleave, which basically means free for all. As many threads as you want at the same time, I will do my locking myself, and it will shoot my foot off at some point. Or may interleave, which is kind of cool. You can add a static method to basically define whether or not you should allow multi-threaded at this current time. No idea how you're going to use that, but it's probably, if you're smart enough, you can probably find a way. Also, I haven't done my entire demo showing you how to do cluster clients, and I'm going to tell you that please do not use iCluster client. iCluster client is cool for demos, but there's a big problem. Communication between the cluster client and the cluster is completely unencrypted. You cannot encrypt it. So you have to put your silo on the internet in a public fashion so that everyone can communicate with it if you want to use the iCluster client. So only ever use the iCluster client if you control the network that you're on, so you can make sure that nobody can get into the network to do the communication. So why did I show it? Because it's the simplest way to do it. A much better way, and I'm actually not going to implement this, but I'm going to show you this quickly, is to remove the cluster client and put an API in between. So in this case, I'm doing a web API here. It's an old school MVC application. And I basically tell this ASP.NET Core application that I want to use Orleans, which basically means that I'm now putting a silo inside of my ASP.NET Core application, which is fine. But because I'm registering the silo inside my ASP.NET Core application, it can talk to any other silo in the cluster. So you can have some silos running as part of your application, but you can then also have other silos running in other applications or consoles app or whatever you want separately. And then inside of my controller, I basically get an iGrain factory injected, and I do grain factory get grain, and I get the grain. So I basically put an API in front of it. So instead of having my simulator down here go and say cluster client dot do this, do that, I do an HTTP call to an API, and then I have the API talking to the backend. The reason that I haven't implemented that is because the other way around, doing the location tracking stuff, would mean that I needed SignalR and a bunch of other stuff to actually get that to work, which was just too much work. You get the general gist, I hope. So please, even if I used a cluster client for my entire demo, I'm now telling you to don't use the cluster client because that's a bad idea. But for demos, it's really cool, and for playing around and trying it out, really great. Try otherwise to get your cluster client, or sorry, your silo inside of your app, then talk in memory to your silo and let your silo talk to the other silos. That's fine. But all of it is unencrypted for performance reasons and some other stuff. So make sure your network is safe. Other than that, got 1 minute to go. Thank you so much for listening. If you have any questions, I will be around the rest of a few more minutes, and then tomorrow just grab me if you have anything. If you want to look at code, use that address. Don't use that address. Use that address in lowercase. Unfortunately, the font only supports uppercase, and bit.ly is case sensitive. So please, that address, but lowercase. I know, stupid, but you remember it now because I told you. Thank you so much. Oh, don't forget to do the evals if you like the session. There's lots of green things out there. If you didn't like the session, come tell me why it was bad. I will explain how good it was, and then you do a green one, okay? I'm also 6'4", 220 pounds Viking, so if you want to, yeah.